Is everything working? Someone let me know if they can hear me.
I can hear you.
Okay, good. We are finally ready to do that. Yeah, sorry, I don't really teach, so I don't really have my stuff ready, but we should be all good. Let us, I guess, start. So today will be all about circles. So circles they look simple shapes, right? They look like they're pretty simple shapes, but they're actually super complicated. And we're going to be going over some of the very basic stuff that we have to learn about circles. So let us start there. All right, so here we have a lovely picture of a circle, and we have in the middle, its center. So this is a circle. And we're taking breaks from polygons, right? We learned about triangles, we learned about quadrilaterals. So now, what happens if we have a shape with 0 sides or 0 angles? So for instance, you remember that a triangle has 3 sides, right, and 3 angles. A quadrilateral will have 4 sides and 4 angles. But this shape has 0 angles and 0 sides, at least technically. So let us go over this shape, this very interesting and unique shape. So this is the basic definition of a circle. You really don't have to write this down unless you're doing like competition and you have to know this. But the basic definition of a circle is a collection of all points that are a fixed distance away from a point. So this makes sense if you're like, if you know what a circle like does and you know what a radius is. It just means like from the center, you see this point in the center? That is the point that we're talking about in this definition. All the points on the circle are going to be an equal distance to this point. So let's say I just choose a random point like right here on top of like the top left of the circle. So if I measure the distance between this point and this point, the middle, it'll be the same as from the middle to another point. So right here. So basically any point on, see this red circle, any point on the red circle will be an equal distance to this middle point in the center. That's basically just what it means. And that point, because it's in the center, is called the center of the circle. It's pretty obvious. There's nothing too crazy going on there. It's just the center of the circle. And the distance between the center and the point, so from this middle, the center, to any point on the circle, so any of these red like dots or red lines on the circle, so from this to this will be called the radius. And any line segment between the center and the point is called radius. We just did that. And this see this definition in bold like I was talking about. Yeah, this definition is one of Euclid's postulates that we learned on the first day. It's like honestly, unless you're taking like history of math or you need to know about Euclid, you don't need to like know this. But it's just interesting to know the formal definition. It's not like some people will say the formal definition of a circle is a round thing, like a wheel or a tire or something like that. But that is not a very good and rigorous definition of a circle. So we're going to be using the one in bold whenever we are talking about circles. Okay, so onto the kind of controversy regarding circles. So if you look at this bottom picture down here, you might be able to see where I'm going. So you have a triangle with 3 sides. It looks very far away from a circle, right? Looks nothing like a circle. Okay, but what about this square? Well, the square is getting, it's not really a circle, but it's getting kind of close. And how about this pentagon? And then this hexagon, and then this heptagon, octagon, nonagon, and whatever this is. So as you can see, once we start increasing sides, we start gaining more and more. It starts to look a lot more like a circle. Like from a triangle, it looks nothing like a circle, but once we reach like an 100gon or 1000gon, it will start looking very close to this circle that we see at the very bottom right. And as we increase the sides, the more it looks like a circle. So the question begins, what happens if we keep adding sides? Like what if we never stopped? So like this has a finite amount of sides. So this is like, if you count all of them, it would probably be like 100 or something. But what if there was way more? What if there was an infinite amount? So I think the question becomes, does a circle technically have 0 sides or infinity sides? So if we increase the amount of sides, does it become 0 or does it become infinity? So that question you guys should think about. Maybe if you want to like input in chat, you want to tell me if do you think it has 0 sides or infinity sides? I'm kind of curious to see what you guys think. If you look at this graphic, it looks like it might be infinity, but technically a circle doesn't really have any edges, right? It doesn't have any vertices. Is it 0 or infinity? So you can just like private chat with me or Alan, or in the chat in public, like you can tell us what you think. So you can make a very good case for both of them, but it's really, I think, up to preference. Like I don't think there's a formal definition, but it could be either or, right? So it's just an interesting thought to keep in mind of. So it's not too important, but it is very interesting. So let us continue, I guess, while you guys keep inputting to the chat. There's no right answer. There's no wrong answer, at least. At least I don't think so. So you don't have to be worried if your answer is different from everyone else. Okay. So before we continue, we should probably go over the circle dictionary. Don't mind this line, this blue line right here. It'll be important later. But this is the circle dictionary. So first, let's start with diameter. So diameter is going to be very similar to radius. We just learned what a radius is, but what about diameter? Okay, so we're going to be learning what they all mean right now, but right now we're just showing what they look like. So this is the diameter. A preview of the definition. It goes through the circle. It touches the circle's endpoints, and it goes to the center. So right here, it will be in the center approximately, and it has to go to the center, or else it's not diameter. So technically, a diameter means the widest part of the circle. So if you measured, like it's impossible, but if you instantly measured every single, like from the tippy top, so like you took a ruler and you measured the tippy top, it's 0. You measured this part, so this part is like 1 inch, and this part is like 2 inch, and 3 inch, and so on. The widest measurement you will take is the diameter. So this is the widest part of the circle. The diameter is going to be the longest line that you can make in a circle. There is no other line you can make. And you can make infinite diameters too, right? So you can make a diameter that go from here to here. So right here, you can make a diameter go from like the bottom left all the way to the top right. You can do all kinds of things with diameters, but it has to pass through the center. That ensures that it's the widest, the largest line you can make. Okay, so let's go into the radius. So this is the radius. It's going to be half of the diameter, and it starts from the center to the endpoint. We just learned what it is in the beginning. It's just from the center to the edge of the circle. There's nothing too important there, but the important thing is that the radius is always the same. So in a circle that has radius 6, it will always have radius 6. It will never have another different radius, because circles are uniform, and no matter how you rotate it, it will always look the same. And chord. A chord is going to be very different from what we just did. So it is going to be a line that goes through the circle and hits it twice. So yeah, we're going to learn about this later. Just know that it goes a little bit this. And technically, a diameter is a chord. It's just the longest chord in a circle. So a chord just has to intersect at 2 points, right? And the diameter is just a chord that's the widest chord. How about an arc? Well, an arc is actually a portion of the. Let's say it starts at A and ends at B, right? Instead of going from a line like this, a direct line, it's actually on the circle. So you're gonna follow on the circle onto B, and that will be an arc. See this red portion? Yeah, that's the arc. If you made a chord, you can make a chord with A and B. So you can make a chord like that, or you can make an arc. Similarly, you can make an arc for here, like A and B right here. We're gonna be learning about this later, so it's not too important to talk about it. So we're gonna move on, and we're gonna learn it a bit later in this class. And tangent. Okay, so this one only touches the circle at one point. And there's a very interesting property that all tangents are perpendicular to the circle's radius. So it's just an interesting fact. We're gonna be using this way later for different problems in math, but we're going to first just go over the basics. And finally, we have the secant, which is basically a chord, except it can move on forever. So we're gonna learn the difference between them today. So don't worry if the chord and the secant seem very similar. You might say, oh, one's a line segment and one's a secant. But technically, if A and B had endpoints, so if it was a line segment like this and here, it would still be a secant because it doesn't end on the circle. So we're gonna be learning the differences later. Don't worry too much about them. This is just a visual reference if you're taking notes, just to make sure what they look like. You don't really have to know what they mean yet. Okay, so first, this is another very good picture of all the stuff in a circle looks like: the tangent, the secant, the chord, the diameter, the radius, and the arc. So yeah, so these are all like the pictures. If you want to make this instead, if you want to have them all in one picture, you can do that. Here's another one that's also it's a little bit messier, but it's colorful, so I like that. Yeah, so there's a chord, a radius, a diameter, a secant, and a tangent. It shows like the perpendicular, I guess, property that tangents have. So I guess it's also kind of useful. So anyone who wants to kind of like replicate this, you can go ahead and do that. But we're gonna move on a little bit. Okay, so first, let us learn about diameter and radius in depth. So we went over a little bit about the definitions, but what about like what do they do? So let's see. In a circle, it's arguably one of the most important features, the diameter and the radius, right? Because the diameter is kind of the widest point and the radius is half of that, but it's also the definition, the very exact definition of a circle. So yeah, we have the picture of a diameter here and a radius. And it's a very important relationship that diameter is equal to 2r. So you can see that this diameter is the widest part of the circle, but it's also equal to 2 times this radius. It's just going to be from this point to this point is actually two radiuses combined together. So from the center to this point is one radius, and from the center to this point is another radius. So you can prove that very simply. You can say that this is r to the center, and this is also r. So yes, r plus r is 2r. So that is pretty, like, I think most of you probably know this, but it is one of the quintessential, I guess, properties that a circle has. And it can help us calculate many different things, such as the perimeter, which we'll be learning today, and the area, which we will be learning another day. So we will be using this later on to figure out many different properties. So unlike with squares and triangles, circles do not play well with rational numbers. So like a rational number is something like 2, negative 100, 0.52. Basically, a rational number is a number that can be expressed as, I think, a fraction. So 2 can be represented as 2 over 1, negative 100 can be represented as 100 over negative 100 over 1, and 0.52 can be represented as 52 over 100 or 26 over 50, and so on. Yeah, Alan can go a little bit in depth on that, what that means. But we're going to be to the magical world of irrational numbers, which is not rational, meaning that no matter how hard you try, the number will never be expressed as a fraction. So let's say we have the number 0.000225, like all the way to infinity. You can never have that as a fraction because I think that's just how it works. But going on a little bit into that when we reach pi. Pi is a very cool number, but we're gonna be learning that today. Okay, so let us have like a warm up basically these questions on diameter and radius. So hint, remember that diameter, I'll write this in chat, diameter is equal to 2 times the radius. Whoops, let me go back. Okay, there we go. And then, bro, what is going on? Ugh. Okay. Whoops, I'm going to reshare that. Okay, there we go. All right, so this isn't too bad, at least compared to what we have later. So yeah, I ramped up the difficulty about some of the questions because I know some of you are pretty fast at these questions. So first of all, I gave 2 questions, I guess, per slide, and we're gonna have some more difficult questions coming on later. So be aware of that. So the first question is super easy. It is just figuring out the relationship between the radius and the diameter. And like I said, the diameter is always equal to 2 times the radius of the circle, aka diameter equal to 2r, if the radius is equal to r. It could be also, if the radius was x, you could say 2x. If the radius was 4r, you could say 8r. It doesn't really matter. It just has to be 2 times whatever the radius is equal to. Yeah, so we already went over that. Okay, so what about this question? So this question kind of confused some of you, I guess, because the wording is a little strange. I will have a picture at the very end. So we're going to go over this one first. So first, we have to figure out that it is going to be a circle inside another circle. We can say it like that because if a circle's radius, if the diameter is the radius of a circle with diameter of 276, so the circle will look like this. Okay, let me find the circle. So it will look, right? We have one big circle with diameter of 276. This is the blue line. It will have a diameter of 276. The circle's diameter is the radius of this circle, so it's going to be like this. So the radius of the bigger circle is the diameter of the smaller circle. So this is the diameter of the smaller circle, which is the radius of the bigger circle. And now, and the question asks for the radius of the smaller circle. So you just have to find basically 1/4 of this. So let's go over the question. So the smaller circle's diameter is the bigger circle's radius. So the bigger circle's radius is 138, right? That is this blue line. This is 138. Okay, so the smaller circle's diameter is 138. That means its radius is 69. Thus, the smaller circle's radius is 69, which is pretty nice. And that would be this, I guess, graph. So yeah, this question is a little wordy. And you have to kind of try to figure out what it means, but overall, it isn't too bad. So if you could figure out, like, if you can draw this and try to kind of figure out, oh, this is a big circle with a big radius, a big diameter, which is the radius of that is the diameter of the smaller circle, and you have to find the radius of the diameter of the radius of the bigger circle, then you can figure out that the radius of the smaller circle is 69. And if you're going super fast and you drew this first, you can figure out that this is actually 1/4 of 276. And since 276 divided by 4 is 69, you can figure it out super fast. So that is a very fast strat you can do, but you can just do it slowly like this, and that's fine. Okay, so we did diameter and radius. How about tangency? So tangency is a line that touches the circle at one point. So let's see, we'll go over that. So it might seem super simple, right? It is a line that touches a circle at one point. But interesting enough, it has to always be perpendicular to the circle's radius. And this is pretty important in physics. I guess when you're trying to find centrifugal force, I think. Is that right, Alan? You might want to confirm that because I really don't know physics that much, but we do use this quite often to actually figure out problems that you need to use right angles. Wow, Pythagorean theorem alert. So you can see a little bit of Pythagorean theorem creeping up in here, right? Anytime you see a right angle, think immediately, oh, Pythagorean theorem. So right angles should always be an alert for Pythagorean theorem or another kind of like triangle property, like the triangle functions, sine, cosine, tangent. You can all use those. Law of cosine, you could use that too. But we're not gonna be using that because that's trigonometry. We're not doing that. So yeah, just know that a tangent line always touches it at one point and is always perpendicular to this line. So okay, so this one is, we're gonna be using that property. So let us try to find if the distance between the point of tangency and the point A on the tangent line, given that the radius is 9 and the distance from point A to the center is 15. Okay, so this question might seem pretty impossible at first, but let me warn you. Let me, I guess, give you a hint. First of all, we have a perpendicular line, right? And then we know the radius, which is this line, and we know the distance between the center and A. So we can make a line from here to here, an imaginary line, which is 15. So now we just have to find what this is equal to. And if you can figure out what that is equal to, then you can figure out this problem, meaning you are a genius. So I'll give you guys maybe like 5-ish minutes to do it, and then I might give you a break. So you could try this one. This one is a little harder than before, but it's not too hard if you know what you're doing. So good luck, and I'll see you in like 4 minutes. Okay, so apparently this question is a little easier than I thought. Oh, it's probably because I explained it because I'm such a genius, but we can use the common, I guess, Pythagorean theorem to try to find this. So let's first draw out what we're going to be doing. So first, let's draw a line from the center to the point A, because that's what the problem gave us, that, I guess, measurement. So it said the distance from point A to the center of the circle is 15. So this is the center of the circle to point A. So that's going to be 15. And it says the radius is 9. So the radius from the center to the end of the circle is 9. So now we can pretty much see how easy this is. Once you figure out that, oh, we have a right triangle and we have two sides. All we have to figure out is the last side. What Pythagorean theorem? So let's just say this side is going to be x, right? So let's say this is x, and now we're going to set it up. So anyone who knows the Pythagorean theorem, 3, 4, 5, you can immediately find out the ratio, and you can figure out that, oh, it's 12. But we're going to figure out first. So x squared plus 9 squared is equal to 15 squared. X squared is equal to 144. So 225 minus 81 is 144. And that means x is just equal to 12 because x squared is equal to 144. Therefore, x is equal to 12. It is not loading. Okay, there we go. So x is actually equal to 12. And we have figured out the distance from point A down here all the way to the point of intersection right here. So yeah, this question is, I know this might seem hard, but we have basically learned all of these, I guess, we've learned all of these concepts. We've learned Pythagorean theorem. We learned what a tangent is, and it's not really hard once you piece together everything you need to know. So Alan, not Alan, no, TA, but Alan with an E, just, I guess, try to apply everything that you learned, and you can get this question. So honestly, it was just trying to figure out. That's basically just what math is. You can use what you've learned in the past, and I guess apply it. Like, you don't have to be in any kind of grade. Some people in college can't even do this because they never learned this, because they are not that advanced in math. But once you figure out all the basics, you can pretty much do this question. Okay, so I might give you guys actually a break. It'll be kind of short because we had that kind of I guess slow start. So I'll give you guys a break. I know you guys want it. So next part does not get easier, Alan. Don't do not tell them that. I'll give you guys like 5 minutes. So see you guys at 8:36 or whatever time you guys are. So yeah, have fun. Go get a snack or go to the bathroom. All right. If you did not have a break and you're wasting your time away inside the chat room, that is completely fine, as long as you disengage your brain for a sec. But everyone should be back right now. If you left, that is your loss. But we should be going back into chords and secants and leaving the magical land of olives. So let us continue. So like I said, you might look at this picture, right? And you might say, okay, so we have AB and AB, right? They're completely different. So what's the main difference of these two? Well, just by looking at them, it's pretty hard, right? You probably don't know what it is. And obviously, they're both lines that intersect the circle at 2 points. So like the tangent, it intersects the circle at 1 point. But what if about a line that intersects the circle at 2 points? So what's the real difference? If it's a virus, ban them. Ban them, Alan. So first, let's talk about chords. So the basic definition of a chord is a line segment or just a line that intersects the circle at 2 points, right? However, this also means that the endpoints are on the circle. So you can make some pretty interesting problems that involve radius. So this is like the difference, I guess the difference from a secant to a chord. The chord has to be on the circle. It cannot be a little bit over, it cannot be a little bit under, it has to be on the circle, 2 points. And that is the difference between a chord and secant. Okay, so let's go over the secant. So basically, a secant is a circle, is a line that intersects a circle at 2 points as well. It can also be a line segment, but we're going to be talking about that later. That it doesn't mean it, however, it doesn't mean it has to be on the circle itself. It could also be like this. So here we have a secant that intersects the circle at 2 points, right? However, it doesn't end on the circle. And these are technically two secants. So we have one secant here and one secant here. And anyone who knows what the power of a point is and knows all these cool theorems that this picture secretly has hiding. So this picture is a lot more interesting than you think, even though it seems like just two secants. It's also called the power of a point, and it is one of, I guess, geometry's most common theorems or common equations. We're not going to be learning that today, so just know that a secant is just a line that intersects it twice, but it doesn't end on the line. So we have one endpoint here, but we don't have an endpoint here. Yeah, it's pretty much just similar triangles, but you really don't want to, you want to memorize the theorem instead of doing similar triangles every time. So we're not going to be learning that at least today, so take it as you will. Yeah, we're going to be learning about that later, so keep an eye out. So speaking of chords and secants and Pythagorean theorem, cough, cough, you'll be needing it for this question. We have a question here. So let's say we have a random chord in a circle. So let's say we have a chord that's length 12, right? So this chord, this red line, has a length of 12. And the circle's radius is 10. So can you find the distance from the center of the circle to the center of the chord, to the center of the chord? So from here to this chord. So let's see if you can try to figure out something to use. You can use trapezoids even to figure out how to get this question to work. So I guess I'll give you guys like 2 minutes. This is not too hard, and you guys can try this one. Another hint: radius is the same, no matter, it has to be from the center to a point on the circle, and it also has to be Pythagorean theorem. So watch out for that. Okie dokie. It is been 2 minutes, and this question isn't too difficult if you know what you're doing. If you've seen this kind of question before, then it should be a piece of cake. So let us try this question. So first, let's just get rid of that for now, and we're gonna just focus on this chord. And we can make a radius. So, like I said, a radius is always the same on a circle, no matter where it is. So as long as from the center to a point on a circle, it is the same exact length. Therefore, the length of this orange line is 10. Whoops. Okay, so we're gonna bring this line down. So we want to find the distance from the center to this point, right? So we're gonna draw a line down, and we're gonna say, oh, it actually bisects this chord down here, and makes it 6. So it was originally 12, but then we bisected it to make it 6. The radius is 10, like I said. So this orange line is 10 because it's a radius. And finally, we have x. And now again, you can see we have another Pythagorean, I guess, triple. So we have a lot of those today. So you might be starting to get the hint of what we're trying to do. We're trying to enforce the fact that you're using your past, I guess, theorems to try to figure out how to solve this problem. And it is a circle that uses triangles. How crazy is that? So obviously we're gonna set that up again. X squared plus 6 squared is equal to 10 squared. X squared is 64. X is 8. So yeah, that one's a pretty common, like I guess 6, 8, 10, pretty common. So you probably memorize that. Or you can know that it's a multiple of 3, 4, 5, because 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So yeah, so you could figure out like that, or you could just do it the old-fashioned way. I think once you get to really, really big numbers, like 400, 300, 500, you probably shouldn't be doing Pythagorean theorem, because you're gonna get like numbers in like the millions. So you should probably just use Pythagorean triples like that, and use multiples to find that out, but whatever. Okay. Whoops. Okay, so finally, the perimeter of a circle. So that might be seen very counterintuitive, right? So it might be kind of strange. So if you recall, the perimeter of a shape means the sum of the distance of the side. Well, what that just means is if you take the length of this side, and this side, and this side of a triangle, the length of all 3 sides, you get the perimeter. How about the length of the quadrilateral, like a square? You can just figure out the length of all the sides, add them up, figure it out. Hexagon, figure out all the length of the sides, add them up, perimeter. Okay, so can we do that with a, can we do that with a circle? So by our definition, a circle either has 0 or infinity, infinity like sides, right? So how can we measure any of the sides, and how can we even figure out how to do this in the first place? Okay, so let's not worry about that for now. But you can also basically pretend. Let's semi informally define the perimeter. So let's say you were walking on this triangle. You started at this point, the tippy top, right? And you walked on this length, and you walked on this length, and then you walked, and you ended back where you started. So how far you walked? So let's say you had a watch that can measure how far you walked. That, like, whatever the number on the watch would say is the perimeter. So similarly, you could walk on this decagon. You can start from this point, the tippy top point right here, and walk all the way around. Stop there, check your watch, and see how far you walked, and that will be how far you walked. Okay, so let's say you do that on a circle. You start at the very tippy top of the circle. You walk all the way around, and you reach the top again. So the number on your watch, first of all, would be an irrational number, most likely. And there's a special name for the circle's perimeter. It's actually called the circumference. So unlike every single other shape ever, it does not have a perimeter. Actually, it's called a circumference. It's just a fancy word. I'm pretty sure it's like Greek for something, but it's pretty important to memorize what this word is and what it means. It's just the perimeter of a circle. Not too difficult. Okay, so pi. Let's talk about pi before we go on to the perimeter. So pi, as you can see, is a lovely slice of blueberry pie. I think it's blueberry pie. I do like myself some pie, but unfortunately, you can see we're actually not going to be talking about pie. We're going to be talking about this pie, this shape right here. So this is actually the Greek letter pi, which is going to be used like everywhere that you have it. So this is actually how you write pi. So if you want to write it, you can say two, like a double T if you combine 2 T's. And in a circle, what pi means is the ratio of the circumference to the diameter. So this is just fancy terms for this equation. Circumference is equal to pi times the diameter, which is equal to 2 times pi r. So usually we don't use the diameter because diameter is unimportant. It's not as important as radius. So usually we say circumference equals 2 pi r. This is the very important equation that you use like pretty much every time you work with circles. Circumference C, or you can use C. You don't have to use this large word. You just say capital C. Capital C is equal to 2 pi r. Why is it equal to 2 pi r? Because it's equal to pi times the diameter, and the diameter is equal to 2r. So pi times 2r is 2 pi r. So you can ignore this second line. The second line just means this equation. Don't memorize this second paragraph. Memorize this equation, and that'll be all. So I was talking about irrational numbers before, right? So let's, I guess, formally go over what it means. So an irrational number is a number that never ends. Well, that's not exactly right. It's a number that cannot be expressed as two rational numbers. So if you took, I guess, 5/2, you can never make pi. You can never take any number over another number to make, yeah. So for instance, 1/3, like in chat, is infinite. It never ends, right? It'll be 0.333333 forever and forever, forever. But since it's 1, which is a rational number, divided by 3, which is also a rational number, it's a rational number as well. But you can't, I guess, have a number divided by a number and have pi, because it's an infinite number with seemingly randomness, and scientists are trying to figure out like the infinite, if there's a pattern in pi. They've never found it. I think they've gone to like the billions and the trillions. They've gotten super far into like pi's digits, but they haven't found, I guess, they haven't found any progress in it. They just know, like, at this point we've gotten so like it's insignificant at all to anything in real life. So in general, all you have to remember is pi is approximately 3.14. If they ask you, is like a circle, if we have a radius of 6, you can approximate that by plugging in 2 times 3.14. You can plug in like pi as 3.14. That is typically how you could go the extra step and say 3.14159. That's typically how far people would go. 3.1415926 and so on. And fun fact, you can almost write pi as these two numbers. They get very close, but they aren't exact. So this one is a famous one, 22/7. Sometimes we use this one if we don't want to talk about this. And famous mathematician Ramanujan figured out this one, 355/113. This one is really close to, I guess, the first few digits of pi, surprisingly, because I think it gets to like the 7th digit or 9th digit, and it's just 355/113. So if you want to be extra cool and you want to figure out, oh, what is some more digits of pi? You can take these two fractions, divide them, and you'll get very close to pi. You could try this out for yourself. And yeah, so I guess this is, I guess, a very interesting page of pi. Not the food, even though the food is way more interesting than the number. We can continue. So, can you find the radius of the circle if the circumference is 8? And can you find, I guess, the second question? You can read it for yourself. So I'll give you guys maybe a few minutes to try to solve these. So we're running a bit low on time. I'm sorry about that. We're gonna have to delay the class a little bit. So hopefully you can hold for that. So I guess try to solve these problems in 2 minutes, and I will be back with you. Also, please do not chat wall the chat with pi. I know it's kind of cool. It goes on forever, but I really don't want to use pi forever. So solve the problem first. By the way, do not be afraid to have pi in your answer. All right, so that's been indeed 2 minutes. So these questions are a little harder, but they're not too bad if you are unafraid to do, I guess, to put pi in. So first question, is the radius of a circle if the circumference is 8? So first let's have the equation. So C is equal to 2 pi r. That's nothing too like groundbreaking, right? So C is actually 8. So 8 is equal to 2 pi r. Therefore, we can divide both sides by 2 pi and figure out that r is equal to 4 over pi. So that is the answer, and radius is equal to, so some people will be like, oh no, the radius is actually an irrational number. That's fine, because this is the correct answer, 4 divided by pi. In a competition, if you wrote 4 divided by 3.14, or like whatever 4 divided by 3.14 is, you'd be wrong, because it's not exact. You have to be exact, so I kind of prefer 4 divided by pi. So like those who got it, you're good job. So yeah, so this one is a little tricky, I guess, if you're not too familiar with how to, I guess, format these questions, but it is not too bad. The second one is kind of the same thing, so let's go over it. So the circle circumference is equal to a square's perimeter. So what is the side length of the square? So first we have to find the circle circumference, right? If we want to find the square's perimeter. So if we know the radius of the circle is 4, we can figure out the circumference of the first one is 8 pi. So the circle circumference is 8 pi, right? So is the perimeter P of the square. So P is equal to 4s. So the perimeter is equal to 4 times the side equals 8 pi, right? And since s is the side, we just divide both sides by 2. I mean, both sides by 4, and figure out that s is equal to 2 pi. So s is 2 pi, and that means the square's side length is 2 pi. I could have been extra mean and asked you the diagonal, but the diagonal is just gonna be 2 pi square root 2. So yeah. So this is the final answer, 2 pi. You guys can look at it a little bit if you want to figure it out for yourself. In general, you just write out the equations and figure it out. Like, it's not too hard. Most people think multi-step problems are really hard, but multi-step are probably the easiest because they have use basic formulas and combine them all together. So it seems very complicated and very, very tough, but it's really not. Okay, let's talk about arcs. This is going to be, I think, the last thing we're going to talk about today. And it's just a portion of the circle. So we have an arc right here, this blue line, and this red line. So we have 2 arcs whenever we have an arc form. So usually there's 2 points. So we have B and C, right? So it usually has the word minor or major, depending on how large it is. So the smaller one obviously called minor. The larger one is obviously called major because it's bigger, and major is big. So we could say that this is the minor arc BC, right? And we have this arc sign over it. That means arc. Or the big one, BDC. We don't have to say major because it includes the point D, right? If we have this point included, we don't have to say major arc. You can say major arc BC, or you can say BDC, because you follow the line, you start at D, you stop at C. So you can say that, and that's basically how it's formatted. So obviously the word minor is the smaller one, the word major is the larger one. And if they're equal, let's say they were like 180 degrees. So we have B here and C here. So they were both equal. So the minor arc is the same length as the major arc. It doesn't matter. Like a problem that uses it, since it's the same length, it doesn't even matter anyway. So don't worry about that. So these arcs happen to form angles. So if you see this picture, spoiler alert, the first one is the central angle. Why? Because it's just the angle that it forms with this, I guess, the center. So this is the center of the circle, and these are two endpoints of the arc. So this is the y, this red line is the arc, this one, and then the measure of the arc is x squared. So whatever this angle is, that is also the angle of this arc. And the second one is the inscribed angle. So let's say we have another point here. We have a point here, a point here, a point here. So any of these points on this side will be 1/2 of this side. So some very sneaky mathematicians have found out that the inscribed angle is always 1/2 of the central angle or the arc's angle. So let's say this arc, this red line, is equal to 50 degrees. So this inscribed angle is 25 degrees because it's 1/2 of 50. So yeah, so this one would be 25 and this one's 50. And by the way, any point on this major arc outside of this, any point on this will always be 25 degrees with this arc. I guess, Alan, I don't know if there's like a reason why, I forgot. But any point on this is always equal to this 25, at least if this is 50. It's always equal to 1/2 of x. Okay, measuring arcs. So we can define as a angle, right? So there's an angle. If we can say, oh, the arc is 25 degrees, but what if we wanted to figure out the length? Okay, but we just don't know a perimeter, right? And since the arc is on the perimeter, how do we use that to figure out its length? So we can pretend that the circumference is a central angle of 360, and if we know the angle of the arc, we can figure out the length. So let us find an example. So let's say we have an inscribed angle of 15 degrees. And we want to find a percentage of the circumference of the arc. So we have this very neat, I guess, picture. So given that the inscribed angle is 15 degrees, so there's an angle right here, that's 15 degrees. So central angle is equal to 2 times the inscribed angle. The central angle is 30 degrees. That is 1/12 of the entire circle. And the arc is 1/12 of the circumference. So you can use like the angles and try to find it all of the stuff to figure out, I guess, the length of the arc. So it's gonna be 1/12 whatever the circumference is. I think we just did this. So I'm gonna do an example, and then we're going to, I guess, do one last question, and I'll let you go. So given that the angle of the arc is 72 degrees and the radius is 52, find the length of the arc. The radius of the circle, by the way. So first, find the circumference, right? Which is 5 pi, because 2 times 5 over 2 pi. Circumference is 5 pi. Then find the ratio of the arc, right? So the ratio of the arc is 72 over 360, which is 1/5. And since the arc is 1/5 the circumference, the arc length is pi, because it's 1/5 the circumference. So 1/5, 1 over 5 times 5, pi is equal to pi. So this is also will come again if we're doing area. And yeah, so that's pretty much, I guess, simplest, I guess, circle stuff. So anyone who really wants to go, they really want to use the bathroom, they want to eat, like, you can go if you want. But anyone who thinks they can take a challenge, you can stay, because we have 2 more things left to cover. So yeah, David, I guess you can go. Farron, you can go. If you don't have any questions, you can leave. If you do, and if you want to continue, I guess with 2 more things, then you can stay. Anyone who wants to leave right now, you can leave, but I'll continue on. So we have the standard form of a circle, right? So we learned all about graphing, right? We learned about coordinate planes before. So on the Cartesian plane, how do we even graph a circle? It seems impossible, right? But using some clever usage of distance formula and the definition of a circle, we can actually figure out that a circle's formula is this bottom one right here. So H and K is the center. So H is the first one, K is the second point. So let's say X and Y. You can say X and Y. But since we already have X and Y here, it makes it confusing. So the radius is R. So the bottom one is going to be the equation of the circle. This is the one to remember. It seems very complicated at first, but once you use it more and more, it's like super easy. So I'll give you an example. So this one is hard. Like this concept is pretty hard if you don't know what you're doing at first. So I'll go over it first with you. So typically in competition or in your math class, your teacher will give you this question. So she'll make you say, find the center and find the radius of this circle. So you'll be like, this is impossible. I'll never find it unless I guess, but you can't. So first, what's your first step? Well, if you want to find x minus h squared, there's something in algebra called completing a square. I don't know if you've heard of it. Completing a square is ungodly and it's so good. So let us try doing that. First, let's move all of the variables to one side. So the x and the y to this side, right? And then we're going to add 1 and 9. So we're going to complete the square. Therefore, we can make sure that this is squared. So x minus 1 squared plus y minus 3 squared is equal to 16. So from this step to this step, from step 2 to step 3, I didn't do anything except make this square. So if you expanded this out, so if you expanded x minus 1, you would get x squared minus 2x plus 1. And if you expanded y minus 3 squared, you get y squared plus minus 6y plus 9. And that's why the 16 are the same. Okay, but you might be wondering why it went from 6 to 16. Well, because I moved all the variables to this side, but then I added a 1 and I added a 9. Therefore, I added 10 to both sides. So technically, I added 10 to this side, and I'll add 10 to this side. So 6 plus 10 is 16. Therefore, you have 16 over here. And now we're getting very close to the standard form of the circle, right? All you have to do is complete the square, simplify. This is a very, very, very common problem in geometry. So you should be very, very good at completing the square. It's hard at first, I know, but once you do way more practice, especially in school, it become basically intuition. You'll do this as a piece of cake. This will be nothing. And since this is the standard form, the center is actually equal to 1, 3, because it's x minus h, which is 1, y minus 3, which is actually equal to k. So the center is 1, 3, 1 and 3, and the radius is actually equal to 4, because if we go back all the way to this, if you remember this, so the center is h and k, right? Then the radius is r squared. So since it's not r, but r squared is 16, therefore r is 4. So the radius is 4. So yeah, that is how you do this kind of question. It seems very hard. It's not hard at all. It's very, very easy once you do enough practice. So I advise you, if you are very, very scared of this question, do a bunch of practice. It is going to be so easy, especially if you know algebra. I assume that if you know geometry, you know algebra. So hopefully you should know this. And one last question for all of you geniuses in this room. So anyone who does not want to do this question, you can go leave. This question is not for people of the faint of heart. But if you want, you can try this question. I think Alan made this up for no reason. I think he was bored. So you can try this question. I'll give you guys like, however, I might give you guys until someone answers it. So yeah, until someone answers it, I will, I guess, go over it a little bit. And yeah, we'll be done for today. Anyone who doesn't want to stay, you can leave. Anyone who wants to do this question, you can stay. And we're going to go over this question. So I'll give you guys however long you need, and we're going to finish.
Wait a second, you meant the problem. This was a different one.
Yeah, my bad. It should be good now.
Okay, there we go.
I think I am seeing a lot of cheaters in this classroom. So we're going to, I guess, do this question now. This is kind of one of these questions called the internal tangent problem or the external segment problem. And it involves this line right here. And what you have to do is use clever properties of rectangles, triangles, and Pythagorean theorem, and circles. Since all of you are cheaters and have done this problem, I really don't know what to do except explain it. If you understand it, then good for you. If you don't understand it, then you cheated your way and good job. So let's start with this question. First, we can make this, I guess this rectangle right here, right? Since this is a really hard problem if you don't know what you're doing, but I guess all of you know what you're doing. So I'll explain it. Hopefully, no one get lost. So we can extend this since the radius is 1. So this is radius of 1. So this side is also 1 because it's a rectangle. So that means, and this I guess the radius, I guess center from this to this is a perpendicular line. There's a rectangle, and we can do that. And so this line to this line is 7, right? Because the radius is 7. And since it's 1, that means this is 6. Therefore, and since the distance from this center to this center is 10, we can figure out that 6 and 10, and we can figure out that this side is actually equal to 8 because Pythagorean triple. That means by rectangles, parallel sides are equal. That means this side is also 8. Therefore, we can figure out that the final answer is 8, and that is a tangent segment that you can only use by using this method. You have to use rectangle properties, Pythagorean theorem, and the radius, and you can solve it. So it's pretty easy. I don't know. I guess all of you got it pretty fast. So I guess all of you thought it was easy too. Good job for everyone that got it. So that'll be all. If you do not have any questions, you can leave. We will be sending these slides out if you want to go over the last question legit. If you don't want to cheat at all, you can try it for yourself. But you're free to go. I am sorry today was a little bit long. I messed up in the beginning. So yeah, it's all my fault. I'll see you guys on Saturday. Bye.